Welcome to today's Daily Science News Show. June 9th, a significant new finding has emerged from Italy's Campi Flegrei, the largest active caldera in Europe. Christopher Kilburn and his team from University College London investigated the pattern of unrest in the caldera, which has seen several periods of ground uplift since 1950. The team collected seismic data and GPS measurements, diving into the relationship between ground movement, seismicity, and strain in the crust. The essence of their work lies in examining how stress builds up in the crust, ultimately leading to a rupture before magma can burst forth in an eruption. This investigation is like reading the heartbeat of the volcano, tracing stress build-up through the small, local earthquakes that occur. The team had predicted in 2016 that the signs of an approaching rupture would continue after a ground uplift of 30 to 40 centimeters at the most active location, which has now been confirmed with their analysis. But what's really fascinating is that these periods of unrest are not just harmless rumblings, they're changing the structure of Campi Flegrei's crust. This means that the magma beneath Campi Flegrei doesn't just sit idly by, it alters the very ground we walk on. This work is crucial because it gives us a better understanding of when and how volcanoes might erupt, an insight that could potentially save lives. Remember, we're not predicting an imminent eruption, but this research does bring us one step closer to understanding these powerful natural phenomena. The findings were published in the Volume 4 of the well-respected journal, Communications, Earth and Environment. On June 8th, researchers revealed a new milestone in the world of solar energy. They engineered solar cells with a clever layering technique, using a material known as perovskite. Previously, the efficiency of these solar cells was hindered by tiny traps in the surface of the perovskite that captured charge, reducing the power generated. But this team tackled this problem by layering two different types of perovskite, each helping to shuttle the charge away from the traps. They applied a new technique, kind of like making a lasagna, layering a wide bandgap perovskite atop a narrower one. This structure, imaginatively called a bilayered perovskite heterojunction, was designed to reduce loss of energy and to guide the charge more efficiently to the output. This seemingly simple tweak resulted in a boost of the solar cell efficiency from being just pretty good to a whopping 23.8%, with a record-breaking 28.5% achieved in a tandem cell setup. Think about that, nearly a third of the sun's energy hitting the cell is converted into usable electricity, a significant leap forward for renewable energy. Moreover, these cells showed remarkable stability, keeping over 90% of their initial performance even after running non-stop for 600 hours. This exciting research is another major step towards greener and more efficient energy generation, bringing us closer to a sustainable future. You can read all about it in their published paper in Nature. On June 7th, we gazed upon a star that defied our understanding. This is a metal-poor star, which is just like any other star, but it has lower levels of heavier elements like sodium and cobalt. The uniqueness lies in how it formed, from a special kind of supernova called a pair-instability supernova. These are the spectacular deaths of very massive stars that were hundreds of times the size of our Sun. Such supernovae were once purely hypothetical and thought to have existed in the early universe. Researchers analyzed the unique composition of this star using high-resolution spectral analysis technology. They found a significant variance in the abundance of odd and even number elements, like sodium/magnesium and cobalt/nickel. This anomaly is the predicted hallmark of a pair-instability supernova, specifically one from a star over 140 times the size of our Sun. This discovery is crucial because it provides evidence for the existence of these immensely large stars in the early universe, which previously existed only in theory. It's like finding the footprints of a mythical creature, hinting at the fantastic celestial beasts that roamed the early universe. This scientific detective story, uncovered from the depths of the cosmos, was published as a journal paper in Nature. On March 15th, a team of researchers unveiled a new kind of drone, named Pulsar, that puts a unique spin on how we perceive our surroundings. Most drones are limited by their field of view, that's the area they can visually scan. To address this, Pulsar introduces a nifty trick. It constantly rotates, essentially giving it a 360-degree view without any extra power drain. How does it manage this spinning dance? They ingeniously harness the natural counter-torque generated by the drone's single motor. Think of it as turning the typically unwanted side effect into a powerful asset. Besides offering a full panoramic view, this spinning top in the sky is energy efficient, consuming almost 27% less power than traditional drones of similar size. During tests, Pulsar, armed with a LiDAR sensor, an eye that uses lasers to perceive the world, showcased impressive results. Successfully navigating through unknown terrain and detecting both static and moving obstacles. This goes to show that sometimes, all it takes is a different spin on an old concept to make a significant stride forward. This research was published in the 76th issue of Science Robotics. On June 7th, imagine a computer that can process images faster than ever before. In the realm of high-performance computing, a group of scientists from Tsinghua University have just presented a breakthrough. They've proposed a new design called spatiotemporal photonic computing architecture. This mouthful of a term actually describes an innovative way to process light fields, almost like how our brain processes what we see but at an incredibly fast speed. In essence, they've built a model where spatial and temporal elements work together in harmony, sort of like a symphony, where different sections of an orchestra blend their sounds seamlessly. In the context of this research, spatial computing is like having many instruments playing together at the same time, while temporal computing is the conductor controlling the speed of the performance. What's truly revolutionary about their design is that they've managed to harmonize these two aspects, creating what they refer to as a three-dimensional spatiotemporal plane. By using a unique training method, they were able to drastically speed up the image processing. To put that into perspective, imagine a video playing 40 times faster without losing any details. That's a significant jump from what we currently have, and it's accomplished with a much simpler system, requiring 35 times fewer parameters, making the whole process much more efficient. So, why is this important? This new architecture could unlock a future where autonomous systems, such as self-driving cars or unmanned drones, could process visual information almost instantaneously, reducing the risk of accidents and improving efficiency. This work is like an invitation to the future where technology can mirror our vision and beyond, making it a truly eye-opening advancement in machine vision. This exciting research was just published in the 23rd issue of the journal Science Advances.